All right, so welcome again. In this video, we are discussing something about um, relations and functions. Okay, now I'll give you the simple definition how to identify a function from the relation. If I have given a one relation f of x, and let's say I have given 1 2 minus 2 4 and 3 minus 1, and the question is that I want to determine whether this relation is a function or not. So what I'm going to do is that I'm going to look at the values. Okay, so this is always x and this is always y. Okay, so if you see here, if my x value is unique, or if x value never repeats, then the given relation, it is a function. This is a simple definition of that without going into the technical difficulties, technical definitions of the functions. Okay, so this is a function. So next example would be g of x would be -2 minus 1 minus 1 0 1 and 2 and 2 2. All right. So again, I will focus on only and only on the x-axis. This is x. This is x. This is my x, x, and this is my x. So as per the definition, if x values is unique and if it is not repeating, the given relation, it is a function. Always these kind of problems are followed by the two another problems or two another definitions which we want to determine, which is domain and range. Okay, so what is domain? Domain is nothing but all the values which is lying on the x-axis, and range all the values lying on the y-axis. Okay, so if you see here, my domain would be -2 minus 1 0 1 2. Always try to keep it in the curly brackets, and in the range, if I see here, this is my -1 0 1 and 2. And if you see here, I have written the y value only once, although it is appear twice. What do I mean by that? If there are if the y value repeated again and again, you should not be writing it that. But if x value repeats, yes, you have to. Now, another example which I want to prove it is, suppose x and y -5 0 5 2 2 and 2. And obviously there would be three sets of questions. One, whether this is a function or not, determine the domain, and determine the range. So if you look at here, this is, yes, this is a function. Why? Because your x value is unique. Okay, so if x value is unique, this is a function. As far as domain is concerned, is -5 0 and 5. And as I told you, the range will be simply 2. You should not write it 2 twice, right? And I think I missed out this. So domain would be 1 minus 2 3, and range would be 2 4 and -1. All right, so this is the basic definition and how of the relation and function, how to separate out the function from the given relation. So let's practice some of the examples over here. Go to the next page. Some practice. Let's do some practice. If I have 2, 4, 0, 2, 5, and of course you are going to give me the sets function, whether it's a function or not, domain and range. I'll write a couple of problems and then we will solve it all together. Okay. This is 9 minus 2 minus 3, 5, 9, and 1. And after, if it is a function or not, then I'm going to define the domain. Range. And let's do the another piece. 0, 5, 4, 9, 3, and 9. All right. So I have a sufficient data in front of me, and let's begin how to write this, answer these questions. All right. So if you see here, x value is repeated over here. So this is not a function. Okay. These are the order pairs x, y, x, y, x, y. So this is not a function. Now your domain would be 2, 8, 0, 2, and 4 to 5. So your range. As far as the function is concerned, this is yes. This is no, sorry, this is not a function. Not a function. Why? Because of this. Then you have a domain which is 9 minus 3, 9, and range is minus 2, 5, 1. And the last piece would be yes, that is a function because you have a unique value of x. Domain would be 8, 5, 9, 3, and range would be 0, 4, 3, 9, and that's it. Okay, so this is about the functions. Now there is a one beautiful thing which is called as a vertical line test. In vertical line test, what it tells you is that if a vertical line, if a vertical line intersects the graph of a relation, intersects this is graph of a relation in no more than no more than 1 point, then that relation is a function. All right. So the simple method how to digest this is that they will give you any function. What you should do is that you just draw a line, and if the vertical line that's the function in only one and one point, then it's a that relation is a function. Okay, so let's figure it out, and I will prove my point by taking my initial points, which is -5, 0, and 5, 2, 2, 2, and let's take everything on the coordinate plane. All right. Now let's say this is -5, this is my 0, and this is my +5, and this is my 1, and this is my 2. Right. So let's put this in the coordinate plane. This is -5, 2. This is 0, 2. And this is 5, 0. All right. So if I draw this line, it will pass through this one. Okay. But I want to determine whether this is a function or not. And let's say you forget that whether x repeated, y repeated, something like that. What you should do is that you should just draw a line. And if you see, oh, it's missed a little bit here. It's okay. And here. All right. So if you see here, it is cutting in one and only one point. All right. So that's why this is a function. Now, continuation of this, if I give you set of problems like this. So if I have a function like this, then if I have something like this, there's function, domain, and range. So if you see this is a function, yes, because if I draw a vertical line test, it will cut only and only at one point. So this is function, yes. For domain, it will take, if you see here, the function is taking any values from -infinity to infinity. Same goes with range, which is -infinity to infinity. Look here carefully. Again, if I take a vertical line test, it passes. So if I want to answer this question, whether it's a function or not, of course, no doubt, it is a function. Then domain and range. If you see the domain is whatever the value is sitting on the x-axis. So x has no limit. So I would write x as -infinity to +infinity. But be careful about the range, because range will be from 0 to infinity. Okay, and be careful in the notation. So this is range, because the lowest value or the starting value what y takes is from 0. This is my 0, 0 point. Okay, and all the values in this direction. Okay, so this is a bit confusing sometimes. Now if I can write it over here itself. Okay, so if I have something like this, a parabolic function, so obviously you can see that if I draw a vertical line, it cuts the function in 2 points. So obviously this is not a function. This is not a function. All right. So this is one more thing. All right. I think that's pretty enough, straightforward. And in the next class, we will discuss about composite function, and the following videos I will be making on the factorization. Okay, so till then, I will stop here and see you in the next video. Bye bye.